you. I want you. It's like picking teams for kickball. I want you to drive differently.
Roughly 6,000 people work at Vanderbilt. Any one of them can change the world. I'm Jad Abumrad, new professor here at Vandy, and today I'm meeting, bing! You guys excited? Exhausted?
Both of those.
More on the excited.
Okay, good. Doctors Jonathan Sprinkle and Dan Work are taking the pain out of traffic.
Every driver has experienced these jams on the freeway that seem to occur out of thin air. And yet we know what causes them. It's the way that you and I drive.
Dan called me and said, Jonathan, I have an idea for you. Are you interested? The experiment brought everybody to Tucson, Arizona on one of the hottest days of the year. Dan blows the horn to tell drivers, it's time to go now. They have one job, keep up with the car in front of you.
All the cars started off driving at a nice, smooth, uniform speed. And then right before your eyes,
traffic out of nowhere, even though they're just going in a circle.
I might tap on the brakes just a little bit. The driver behind me has to brake harder to avoid crashing, and the driver behind them does the same thing. And so you get these ripple effects on the freeway.
The real trick is what happens next. Dan and Jonathan switch on a remote-operated cruise control to one car, just one. And they tell it to drive at the average speed of traffic. Instead of trying to catch the car in front of you, just drive at the average speed.
Lo and behold, the amount of stop-and-go waves started to decrease.
It's easy to miss, so let's just play it back one more time.
So they're going around in a circle, the traffic waves begin. They turn on that one car, and the traffic waves for everyone vanish.
So we're going to speed up a little bit. Now we're going faster than we were before, but the amount of fuel being used is dramatically less.
What is that? Like, how much fuel did they save?
I think it was about 40% less fuel used.
So one car can do that for 20 cars?
Yeah.
Think about that. One car changing its behavior a tiny bit can affect 20 others. Did they just solve traffic?
No.
Because then you start realizing, well, there's a big gap between making it work in a parking lot to getting it to work in the real world on wild freeways. So then we start thinking, like, how are we going to do it? The complexity from the engineering point of view exploded. I-24 Motion is made up of almost 300 4K resolution video cameras, so that as a vehicle is driving through this 4-mile stretch, it's always visible at least in one of the cameras.
This is our Beetle camera rig.
This is Will, one of the research scientists on the team.
This allows us to have 6 cameras on a single bolt and transmit all that video data over to our data center at Vanderbilt.
Whoa. It actually hurts my head a little bit. I almost just want there to be a soundtrack. What song should be playing right now? Maybe some Brian Eno thing?
I'm thinking of like all great road tripping music.
Dan and Jonathan's team are able to anonymously track all of these cars and plot that information on these massive graphs, where each pixel represents an individual car on I-24. At 70 miles per hour, the pixel is green. 10 miles per hour or slower, the pixel is red.
Why did this car stop? To find out what the cause is, you have to go back in time, downstream.
Wow, so somewhere here, some dip, excuse my language, hits the brakes a little tiny bit too hard, and then that creates a ripple. 15 minutes later, this person has no idea, but they're stuck in a traffic jam.
That's it.
Again, one person, in this case, mucks it up for everyone. So then the question became, could they do the circle thing, but this time on the freeway, and instead of with just one car, how about 100?
We had to develop a custom circuit board to control cars.
What's the thing that kept you up at night?
I have to say a single thing, huh?
This is Matt, another research scientist on the team.
This is a prototype, a way to interface with the cars using this Raspberry Pi.
The idea was they'd use that little box to control the speed of each vehicle.
This is what we assembled 100 of and then installed in all 100 cars.
This wire here would go under the console, plug into a wire that came off of the steering wheel, and then we're ready to deploy.
November 14th, 2022.
4 a.m., people are there making coffee. At some point, we're ready to start the tests. That then is this mad dash.
We're letting the vehicles go as fast as we reasonably can get them out on the roadway. We need to make sure that we bring every driver back safely. That is the only thing that matters.
The 100 cars insinuate themselves into rush hour traffic. A central server controls the speed of each one. And the idea, their hope, is that these cars will form a kind of wave-dampening blanket that will soothe the stop and go and make traffic flow more smoothly.
Did you witness something like the circle experiment, where as you infiltrated rush hour with your semi-autonomous driver systems, did you see it have an immediate effect on traffic?
There are examples where you can clearly see a wave traveling, one of our vehicles drive near the wave, and the wave disappears. In the dream world, it turns green, but I would frankly take it even if it just turned yellow.
Because think of all the stress you would save, not to mention the gas. And if you multiply that savings out to a whole freeway, and then to many, many freeways across the nation, you're saving massive amounts of fuel.
We're choosing technologies that are not in the distant future. They're barely different from the things that we already have available today, and nobody really notices what changed. It's just better.